Welcome back, everyone. In today's episode, we're going to explore one of the most important foundations in artificial intelligence, uninformed search strategies. These are also called blind searches. Why blind? Because they work without any extra knowledge about the problem. They only know what's in the problem definition itself. Sounds interesting, right? Let's dive in. What are uninformed search strategies? Think of it like this. Imagine you're lost in a maze with no map, no hints, and no idea which way leads to the exit. All you can do is try paths one by one, hoping you'll eventually stumble upon the goal. That's exactly what uninformed search does. It generates possible states, checks whether a state is a goal, and keeps expanding until it finds the answer. Different strategies only differ in the order in which they expand nodes. Strategy 1. Breadth First Search, BFS. Breadth First Search is one of the simplest strategies. It starts at the root node and explores all neighbors first before moving deeper. In other words, it explores level by level. BFS uses a queue, FIFO, first in, first out, to keep track of nodes. Imagine you are checking friends of friends on social media. BFS would first check all your direct friends, then their friends, and so on. Properties of BFS. Complete. If there's a solution, BFS will definitely find it. Optimal. If all actions have the same cost, BFS finds the shortest path. But the downside? Memory and time usage explode as the depth grows. Complexity, OBD, where B equals sign branching factor, D equals sign depth of the shallowest solution. Fun fact, if the solution is at depth 16, BFS could take hundreds of years on a normal computer. So, while BFS is nice for small problems, it doesn't scale well. Strategy 2, Uniform Cost Search, UCS. Now, what if actions don't all have the same cost? For example, in maps, some roads are longer or slower than others. That's where Uniform Cost Search comes in. UCS always expands the node with the lowest path cost so far. It uses a priority queue, sorted by path cost. This guarantees an optimal solution regardless of step costs. Imagine you're planning a trip in Google Maps. UCS will always choose the cheapest or shortest route step by step until it reaches the destination. Properties of UCS. Complete, as long as step costs are positive. Optimal, because it always expands the least costly path first. Still expensive in terms of memory and time. Strategy 3. Depth First Search, DFS. Depth First Search is like the opposite of BFS. Instead of exploring level by level, DFS dives deep into one branch before backtracking. It uses a stack, LIFO, last in, first out. Think of it like exploring a cave. You go as deep as possible down one tunnel, and only when you hit a dead end do you backtrack and try another path. Properties of DFS. Memory efficient. Only stores one path at a time. Not complete in infinite state spaces. It can get stuck in loops. Not optimal. It may find a solution, but not the best one. But DFS is extremely useful in practice because of its low memory requirements, especially in areas like constraint satisfaction and logic programming. Strategy 4. Depth Limited Search. DFS has a big problem. It can get lost in infinite depth. The fix? Put a limit on how deep you're willing to go. This is depth limited search. If the solution is beyond the depth limit, it won't be found. If the limit is too large, it wastes time. So choosing the right limit is crucial. Strategy 5. Iterative Deepening Search, IDS. Finally, the best of both worlds. Iterative Deepening Search. IDS repeatedly runs DFS with increasing depth limits. First depth 0, then 1, then 2, and so on. It combines the low memory advantage of DFS with the completeness and optimality of BFS. Yes, it does repeat some work, but that overhead is very small compared to the benefits. That's why IDS is often the preferred uninformed search strategy when the search space is large and the depth of the solution is unknown. So, to summarize, BFS, great for shallow solutions but memory hungry. UCS, best when step costs vary, guaranteed optimal. DFS, super memory efficient but risky for infinite paths. Depth limited, a controlled DFS with a cutoff. IDS, the most practical, combining the strengths of BFS and DFS. And that's the beauty of uninformed search. Even without any extra knowledge, we have smart ways to systematically find solutions. In the next episode, we'll move into informed search strategies, where we'll introduce heuristics to make searching much faster and smarter. If you enjoyed this video, don't forget to like, share, and subscribe for more AI lessons made simple.